All right. Just some pieces of vocabulary here, kind of to start us off. So in a polygon, we need to look out for a couple things that makes it not a polygon. Okay. So it does have to be closed. So this one would be an example of one that's not closed, right? So it does have to be closed. It does have to have three or more straight lines. So circles, ovals, anything with a curved line in it is not a polygon. It can also not cross over itself, and it cannot connect, or it's not connected end to end. So this is kind of a composite where we have more than one shape put together. So those are some examples of not polygons. These are some examples of polygons. You can see that they consist of many different sides. It just has to be closed with no curved sides and not like crossover itself. Okay. I'll give you a quick minute together with your groups to do 1 through 6 on that first page there. So do 1 through 6. Make sure you are paying attention to proper notation. Okay. Rock and roll. Go ahead. Okay. So let's look at number uno. Okay, consecutive. What does consecutive mean? What's consecutive mean? Like if I said, what are two consecutive numbers? What would you answer? 1 and 2. Why? What? They're next to each other, or side by side, right? So 1 and 2 would be consecutive numbers. So if I want consecutive sides, I have two different options for a consecutive side with JK. What would my options be? Good, JM or KL. So remember, when we're writing the name of a side, we got to put that segment marker over it, right, for our notation. So JM or KL, I can put that one as well. I'll just do 1 through 5 since they're here, and then I'll slide over to 2, 4, 6. Vertex, that is opposite of L. So here's L. Opposite would be J. Good. And when we name a vertex, we just name it with a letter. There's no special notation for it. Okay, but then when we move to 5, when we're looking at angles, so it's opposite K would be M, I have to make sure that I put the angle marker with it. Okay, good. Yep. Okay, so angle M, and make sure you put that angle marker with it. All right, moving over to 2, 4, 6. Opposite of KL would be JM. Okay. Consecutive vertices, so you could do a lot of different things here. You could do JK, JM. The only thing you couldn't have is JL or KM, right? Everything else would actually work. So no JLs or no KMs. Okay. Name a pair of consecutive sides. Again, you could have a lot of different things. You could have JK and KL. You could have ML and KL. You could have anything that is two sides touching. All right, just to make sure they're touching. Okay. All right. Regular polygon. This is really, really important. This word regular is very important. So when you see the word regular in association with a polygon, you know that it means two things. It is both equilateral and equiangular. Quick 30-second conversation in your groups. What do those two words mean? Ready, set, go.
All the angles are equal and all
All right, what's equilateral?
sides.
All the sides are the same. What's equiangular? All the angles are the same. So that means if I have a regular polygon, all the sides around the outside should all be equal. All the angles inside should all be equal. Okay? So equilateral, equiangular. A diagonal of a polygon, pretty simple. It just can't go from two consecutive vertices. So from one vertice to any non-consecutive vertice. So any vertice that's not beside it. Okay, so diagonals can be all over the place. Convex and concave polygons. The best way that I've found to remember it is concave caves in on itself. Okay, so concave caves in on itself. That's what I call this little piece right here. So it's caving in on itself, whereas convex doesn't have any of those. Okay, so concave, caving in on itself. Convex doesn't have any of those. Okay. Okay. So for my new people, when I ask for a comfort level, it's at a 4. 4 being I fully get it, I could teach it to somebody else. 3 is I'm pretty close to being there. There may just be a couple trip ups here and there. 2 moves a little further away from that. Maybe I need some a little more practice. 1 is I have a long way to go. I really don't understand a whole lot of it, but I may have a very small basis of what's going on. 0 is I have no stinking clue what's happening right now. You have a question?
You realize you're recording?
I do realize I'm recording. Yeah. No, I was recording because I didn't have video notes for this one. Yeah. So don't say anything I wouldn't say. Well, or some things that I would say. Just kidding. All right. So comfort level out of 4. Cool. We're feeling pretty good about the vocab. Okay. All right. On to the next page. Okay. Oop. Here we go. Okay. So looking at this top box, everybody should know with 3 sides that makes a triangle, and everybody should know what the sum of all the angles inside of a triangle equals, right? What is it? 180. Okay, good. So we can fill that in. Do you guys know the sum of a quadrilateral with 4 sides? Yep, 360. Do you know 5 sides? Google it. Yeah, it's 540. Dang it. I didn't realize I left it up on the board. Okay, and how about 6 sides? 720. So on and so forth. Okay, what pattern do we see here? We're going up by 180. Okay, so let's kind of explore this pattern. 180, why is 180 significant? Sum of a triangle. So we're going to think about any polygon being broken down into triangles. So a triangle is a triangle. Okay, it's just a straight up 180. Any quadrilateral with 4 sides. How many triangles could I break that into? 2 full triangles, right? So break it in by a diagonal. Now I have 2 triangles times 180 degrees for each triangle. That's 360. Then if I move to a 5-sided shape, so a pentagon, it's not a very beautiful pentagon. If I break this into triangles, I could go 1, 2, 3 triangles, right? So now I have 3 triangles times 180 degrees per triangle. That's 540. Okay, then if I go to 6 sides, okay, with 6 sides, I can break it into 4 triangles. Okay, so then I have 4 triangles times 180 degrees, and that's 720. Okay, so now what we need to do is, now that we've broken it down into triangles, and we know that we can just multiply the number of triangles times 180 to get the number of, or the sum of the interior angles. Now we need to find some kind of relationship. So is there any kind of relationship between the number of sides and the number of triangles? So here we have 3 sides and how many triangles? 1 triangle, right? Then we have 4 sides and how many triangles? 2 triangles. Then we have 5 sides and 3 triangles. Then we have 6 sides and 4 triangles. Yeah. So if we take the number of sides and subtract 2 from that, that gives me the number of triangles, because one triangle is 3 sides, right? And then every side that we add after that just adds a single triangle. Okay? So that's where we get this formula down here. Okay, so this formula right here is going to be important, so you want to highlight it. So that's equal to the sum of interior angles. Okay? So it's equal to the sum of the interior angles, in being the number of sides. So if there were 12 sides, you would subtract 2 from that and you would say that there are 10 triangles. And then 10 triangles times 180 degrees would be 1,080 degrees. So that means something with 12 sides, the sum of all the interior angles would equal 1,800 degrees. Okay? Okay, so use that idea and go ahead and do 1 through 6 together with your groups. So 4, 5, and 6 are a little bit of a different question, so you're going to have to brainstorm how you can solve those. Okay, go ahead with your groups. Okay, so number 1, octagon. How many sides does that have? 8 sides. So I have 8 sides minus 2 gives me 6 triangles, right? Times 180 degrees. And what do I get for the sum there? 1,080. Oops. 1,080. Sounds good to me. A 15 gon. So I take 15 sides, subtract 2 off of it to make 13 triangles. Times 180 is a big number. What is that?
2,340.
Thank you. And then a 24 gon. So that's 24 minus 2 is 22 triangles times 180.
3,960.
Thank you. Okay, so pretty straightforward. Then we get to 4, 5, and 6, and it kind of changes it up on us a little bit, right?
Do you just divide by 180?
Kind of.
Okay.
Okay? So 900 is our sum. So now I'm doing 900 equals the n minus 2, which n minus 2 is the number of sides minus the 2 for the number of triangles times 180, right? So what did you say our first step was? Divide by 180, right? So we would divide by 180, which is the correct first step. What are we essentially finding when we take 900 divided by 180?
How many triangles?
Yeah, it would be how many triangles make up that shape, right? So what's 900 divided by 180? Is it like 5? Yeah. So 5 equals n minus 2. So that means that shape could be broken down into 5 triangles, which then when I add 2 to both sides, then I get n, which I know is the number of sides, which equals 7. So 7 sides. Yeah.
I did it like a different way. I distributed 180 into
Yeah.
parentheses and then just did that.
Yeah, it'll give you the same thing. Yep. Just, I think it adds one extra step, but if you are more comfortable that way, that's fine. Okay, so let's do another one with 1620. So 1620 equals n minus 2 times 180. So first thing I divide by 180. And what's that? What's 9? Is that right? So 9 equals n minus 2. So that means it breaks down into 9 triangles. Then I add 2 to both sides. And I get n equals 11 sides. Okay, pretty straightforward. Can I get a comfort level out of 4? Good. Feeling good. Okay. All right, last page here. Okay. Go ahead and try number 8 together with your groups. Go ahead and try number 8 together with your groups. Okay, so what do we need to know before we can really find x? Yeah,
What they all add up to.
good. We need to know what they all add up to. So I need to know how many sides. So 1, 2, 3, 4, 5, 6 sides. So 6 sides minus 2 would be the number of triangles times 180 gives me 720, right? So that means all of the interior angles should add up to be 720. So 720 now equals x plus 140 plus 130 plus 120 plus 90. How many of you forgot this one? Okay, plus 90 plus 150. So what is all that? What does all this stuff add up to? 540? Oh, you forgot the 90. 630. So 720 equals x plus 630. Subtract 630 from both sides. X ends up being 90 degrees. Okay, so x ends up being 90 degrees. Okay. So the only added step that would be new to you there is finding the sum first, right? Okay. So let's look at exterior angles. Exterior angles is a little bit easier than interior angles because remember, interior angles, it depends on how many sides there are. Exterior angles, it's always 360. Always. Always. Okay, so exterior angles always 360 degrees. All you need to really recognize is how to find those angles. So you're essentially just taking one of the sides, extending it out one direction for each. So you got to kind of go out the same direction for each side, and then those make your exterior angles. Okay. Yeah. So those always add up to 360. So go ahead and do 10 together with your groups. I'll give you like 30 seconds. That's all it should really take you because those are exterior angles. All right, so very simply, let's see, I have 5x's, and I have 98 and 162 is 260. And since they're exterior angles, that should equal 360. So 5x equals 100. So x equals 20. Okay, it asked me to find x, so I'm good there. But I could plug that back in if they asked me to find angle measures or anything like that. Okay, so let's look at 11 together. So it says, find the measure of each interior angle and each exterior angle of the indicated regular polygon. What's the key word that I should catch in that statement? Regular, right? And what did regular mean again? Good. Equal angular is the one that we really care about here the most, right? Because we're finding angles. So that means all 45 angles in this 45 gon are all the same, right? So that makes it a little bit easier on me. So what do you think I need to find first? If I'm working on interior angles, what do I need to find first? Good. The sum of all the interior angles, which would mean we need to find the triangles that do that thing, right? So we have 45 sides. So this is all interior. So we have 45 sides. Minus 2 would give me the number of triangles. Times 180. And somebody have a calculator handy that could do that. What is it? 7,740? Okay, so that's the sum. So how would I find how much each one is? Yeah, since they're all the same, just divide by 45. Somebody want to do that for me? So they're 172 degrees each. Okay, so that's for interior, right? Exterior. Okay, so exterior. I again want the sum. So what do all the exterior angles add up to be? Always 360. So this one's a little easier. And then I divide that by 45 angles because they're all the same. And it's 8. Okay. All right, so we've answered the question, but I want to challenge you guys a little bit. Okay? I want you in your groups to figure out an alternative method to solving this problem that might save us some work. So you may use some of this work. You may not use any of it, but I want you to come up with an alternative method and give me a reasoning why, an alternative method to solve this problem that would take less work than this. Okay, so I'll give you guys some time to think about that. Go ahead. Okay, let me give you a gentle nudge in the right direction. So I'm going to kind of come over here. This is not an n-gon. I'm just going to draw a hexagon because it's easy to draw. Okay? But remember, so if I draw kind of a dotted line here for my exterior angle, this is my interior angle, and this is my exterior angle. Okay, so I'm going to shut up for about 30 more seconds and see what you guys can come up with that little nudge in the right direction. So what are we thinking? First off, what's the relationship between the interior and exterior angles? Yeah, it's a linear pair, right? So my interior and exterior angles, based on my picture, my interior and exterior angles are a linear pair. Which, what does it mean to be a linear pair? Good, you add up to 180. So I know that if I look at an inside angle, an interior angle, and an exterior angle, they should add up to 180, right? So I can find one based off the other. I don't have to start from scratch every time. So if we chose one or the other, what do you think is easier to find, interior or exterior? Definitely exterior, right? Because I don't even care how many sides it has at that point. Well, I do because I got to divide by that. But I don't have to find, the sum's a lot easier because it's always 360. So if I found the exterior first, so I found the exterior was 8 degrees. How could I find the interior without doing very much more work? There you go. 180 minus 8 equals 172. So I know if I can find each exterior angle, its linear pair counterpart, or the supplementary angle to it, right? The supplementary add up to 180. So the supplementary angle to that has to be the inside angle, the interior angle, okay? Would it be right or wrong, more right, more wrong, regardless of how you did it? No, not at all. Okay, I'm just kind of showing you how an understanding of these polygons can kind of help. Okay? All right, rest of the time is yours for homework.